Hello and welcome to Ngwasheng Maths Online Academy. My name is Ngwasheng. I'm going to do nature of the roots. Remember, this is part of grade 11 and 12 as well, where especially in question 1, the last question, usually they like to engage with a touch of nature of the roots. And if it's not question 1 under algebra, remember on the function where we are talking about parabola and straight line, they like to also put one of the question that is based on nature of the root. So this is for two different topics. It's under algebra and also under the functions. So for both grades 11 and 12, this is important for you. Like I promised on the previous video that I'm going to do nature of the roots. Yeah, this is the roots. This is nature of the roots. Remember, straight to the point. Let's check. A triangle is known to be discriminant, right? And there's a formula for that. But we call this nature of the roots. Where does this come from? Like, check. According to this, according to quadratic, yes, nature of the roots, we only take that part that is within the square root, hence the roots, nature of the roots. We're only interested in this portion inside the root. So hence we say the formula for discriminant is equals to b squared minus 4ac. You can see that this is similar to that, hence nature of the roots. Nature of the roots also differ based on the answers that we are getting. We come across nature discriminant that is less than 0 is only when our answer is negative. You work out this, you find a negative answer inside the root. Your calculator usually will tell you maths error. So hence we say that discriminant is less than 0 and it will be non-real. When they say nature of the roots, calculate and get your answer. Once you get the answer, just look at the answer and be able to tell what is the nature of the roots of that answer. If the answer inside the roots is negative, we say is non-real. If you get 0 inside that, we say it's equal, it's real, it's rational, it's unequal. Something that is rational, it's any perfect number, like 4, 9, 16, as long as there's a square root for that number, we say it is real. I mean, it's rational. Real is positive. Anything positive is real. Remember, a number can be positive, but it's not a perfect square. If it's not a perfect square, it's not a rational. And when you say it's equal, is when you're getting a 0 inside that. But we are not focusing on the quadratic. Now, my good people, check. Watch until the end. Watch this video until the end. There are 4 problems here which I'm going to work on. Then it will summarize all this. Let's go straight to the point. Calculate the discriminant first. Let's calculate the discriminant. Only after getting the answer, then we can determine the nature of the roots. Now, having this in the form of ax squared plus bx plus c, we still follow that, where our a is 2, b is minus 3, c is 2. So now, the nature of the root says, when they say calculate, now I start here. Now, what is my b? My b is minus 3. What is my a? My a is 2. When my a is 2, what is my c? My c is also 2. Now, negative 3 squared, as long as it is inside the bracket, it's going to be a positive 9. Now, this negative times positive is just negative. What is 4 times 2? That's a 8. 8 times 2, that's a 16. Now, 9 minus 16, we are getting a negative 7. We calculate the discriminant. We calculated the discriminant. We are getting a negative 7. Remember, even if we were using this quadratic formula, this inside the square root, we were going to get something like a negative 7 inside the square root, but we are only considering the negative 7 because it's part of the discriminant. And the discriminant comes from b squared minus 4ac. Now, when we say determine the nature of the roots, that is the second part. The first part was to calculate the discriminant. The second part now determine the nature of the roots. Tell us. Now, negative 7. It's a negative answer. Let's come to this. You can see our discriminant is less than 0 because it's negative. So I can say, okay, now this is less than 0. That's what I see here. Why? And then the roots will be what? Non-real. So I'm going to tell them this roots is actually a non-real. Because we are getting something like square root of negatives. If you punch a calculator here, you're going to get a math error. Hence, it's non-real. And obviously, you can see, once it's negative, it cannot be a real number. Any negative number is considered to be non-real. And any positive number is considered to be real. But a positive number can either be rational or irrational. It's rational only if it's a perfect square. So, yeah, we will come to that. So let us proceed with the second problem. Number 2. I'll try to be quick here. I forgot to equate to 0 there. It's fine. Let me edit on that. Now, number 2, same thing. Determine the discriminant. Now, my b in this case is minus 3 squared minus 4. My a is 2. My c is minus 2. What do I get? I get a positive 9. Negative times negative, I get a positive. 4 times 2 is 8. 8 times 2 is 16. But 9 plus 16 is 25. My discriminant is 25. I judge the answer. What is the nature of these roots? Number 1, look, it's perfect. 25 is a perfect number, right? If it's perfect, that means it's real. If it's real, that means it's rational. Rational, as long as you can have a square root of that, as long as it's a perfect, it's automatically irrational. And it's unequal because it's not a 0. If you got discriminant equals to 0, then we're going to say it's 0. But now, we're going to say is what? Is equal. But this one says unequal. So my answer here is perfect for this one. It's greater than 0 because it's 25. So I'm going to say, when I say nature of the roots, that is perfect. That is real because it's positive. It's perfect because the perfect square. It's real because it's positive. It's rational as well. Anything that is the rational, obvious, there is we can get a square root for this, which is 5. And it's unequal. As long as it's not a 0, we say it's unequal. That's it. That is the nature of the roots. Nothing more, nothing less. Now, let's check the second one. My handwriting, guys, you will excuse me. Now here, again, we are determining the discriminant. This is the discriminant formula, guys. Now, what is my b? My b is minus 3 squared. What is my a? Is 2. What is my c? Is minus 1. What do I get here? 9. Negative times negative is positive. 4 times 2 is 8. 8 times 1 is just 8. So I'm getting a positive 17. Now look, I got a positive number. I said it's real because of it's positive. Now I'm getting a positive 17. Definitely it's real because it's positive. But is this a perfect square? No, it's not a perfect square. And if it's not a perfect square, it's irrational. It's also unequal because it's not a 0. So you see now, it take this. It's not a perfect square. However, it's real because it's positive, but it's irrational. Now you can see how we solve all these problems. But now let's look at the nature of how they ask this in exam. Let's check how they ask all this in examination. All this, yes, might be part of the exam. I think you already know this. You have this now. because I need a space. Now, let's bring the last one here. X squared minus 4x plus k equals to 0. They say to calculate discriminant in terms of k first. That is the first thing. I still use this. What is my b? B is the coefficient of x. I have a minus 4 squared, minus 4. A is the coefficient of x squared. That is 1, the invisible 1 there. But what is c is the k itself. No, not 0. Remember, we are having this. So negative 4 squared is negative 4 times negative 4. That is 16. Negative will remain. 4 times 1 is 4. 4 times k, that's 4k. We answered the first question where they say calculate the discriminant in terms of k. It ends there. But they like to continue. Let me check the question that they can ask here. Okay. They will say determine the value of k if the roots of the equation are real. Determine the value of k if the roots are real. Real we expect to have positive and blah 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 blah. Now, I cannot tell the discriminant as a value. I cannot give the nature of the roots because I don't know my k. So how to get k? They say if it's real, something that is real, we can say it's greater. We can use the term like this is greater. We expect it to be greater since it's unreal. Now, the fact that they indicated that the equation should be real, this is where we say this is greater or equals to 0. So it's me taking this to say you see that this is just me. Why did I choose this? The statement that is provided to say determine the value of k if the equation, the quadratic equation will be real. So I indicated previously that positive is greater, negative is less. So we go with that one, where the roots should be real. So now this is you solving for x. So obviously I must transpose what? My 16, which should be negative 16. Now we all know that from here, if we divide by negative, this sign is going to change based depending on where it's faced. If it was facing the other way, then it will be the opposite. Now divided by a negative side, the one that was greater now become less. They were getting a 4. It changes to become less or equals to 4. Now let's check something. When they say real is greater than 0, so in this case, especially when it's greater or equal, we can still get the answer of 0. We are done here basically, but you can take this 4 and go and plug it there. So that means you're going to have a discriminant of 16 minus 4 times 4. So we are getting 16 minus 16. Then it gives you a 0. So 0, this is real. Like they said, determine the value of k if the roots will be real. So indeed, after getting my k, when I substitute to check the nature of the roots, I'm getting a 0. So that is real, okay? And obviously, you can see it's real, it's equal. As long as it's 0, it's also equal. Real and equal. Yeah, no. On the comment section below, please comment, like, share. I'll do the next video. I'll see what is the next video that I'll upload. Maybe I can also touch on the I've been doing trigonometry. I'll check more trigonometric problems that I can do. Therefore, I'll also switch to functions. Remember, this term we're going to be assessed based on algebra, sequence and series, functions, and trigonometry. Oh yeah, I'll do the next one, which is based on double angles. I'll do the double angles. Thank you for watching.